Hi, this is the next video. What we're going to look at this particular video is creating reverse routes. What happens is, assuming that we've got a Windows 10 machine out here in switch 2, this represents a whole range of computers, and in our Get Well Medical this could be up to 30 computers, but it could just as easily be 10,000 computers. If you can imagine that the client machines are requesting maybe a web page off the web server or some other service off server A, maybe they're logging into the domain or something like that. So what happens is they generate a request and they'll probably do a DNS search to start with, and from the DHCP, these machines out here know that the DNS server is 10.2, which is server A. So they would send a DNS request through, because they don't know where the 10 subnet is, they would send it to their gateway, which in this case is 20.1. The router here says, well, I know where the 10 subnet is, I've got a network card in the 10 subnet, so it will deliver that request packet through this card onto the switch. It gets picked up by server A, which is 20.2, and the DNS in here would then resolve that back to an IP address. So let's just say our Windows 10 machine was actually after a web page. It would resolve the page back to the request back to 10.3. So then the Windows 10 machine would then send a page request to the web server, and again, that's not in the same subnet as this machine, so it sends it to its gateway, which in this case is 20.1, and it's addressed to 10.3 now because it's after a web page. And the router here says, well, I know where the 10 subnet is because I've got a network card in the 10 subnet, so I'll push it out through this card here to the switch. And 10.3, the server B receives the request for a web page and then says, okay, I've got a request from 20.100, because that's what the DHCP range starts at 100. So 20.100 has requested a web page. It's just received the request. It's going to respond back with the actual web page, and when it responds back with the actual web page, it says, well, I've got to get it back to 20.100, and well, I don't know where that is because I've got a network card in the 10 subnet, so it sends it to its gateway, which in our case is 10.1 here on the ADSL. Now, because we've got RIP on this interface card and this interface card here on the router here has inserted into the ADSL's routing table the instructions of how to get to the 20 subnet and also the 30 subnet out here on the wireless. So in here on the ADSL, it knows in order to get to the 20 subnet, it has to push the packet back to 10.254, i.e. this router. So what happens is DNS comes through to here, get a result back, page request comes to the web server doesn't know what to do with it, so it sends it to its gateway, and then the gateway says, well, I know how to get it to the 20 subnet, and pushes it back to 10.254. This router here says, well, I know how to deliver it to 20.100. I've got a card in the 20 subnet, so it pushes it out through that card address to, and the Windows 10 machine will then get the web page. So it's sort of like a handshaking type system, and what happens effectively is Windows 10 through the router to the web server then sends it to the ADSL because it doesn't know how to get it back. The ADSL does know how to get it back and pushes it back to the router, and then the router passes it back to Windows 10. Now we can see an obvious problem with this. What it means is that all requests from anything in the server subnet here is going to get bounced off this interface card here on the ADSL before it gets pushed back to the router and gets back to the 10 subnet, the 20 subnet, which is where all the clients are. So if we've got 10,000 machines out here, or even 30 machines for Get Well, then they're always going to bounce their traffic off this front network card here in order to get the traffic back, which is not a nice thing to do, in that we're hammering this network card here for all responses back to the 20 subnet. What we really should do is request comes through from a web server, and the web server goes, well, I know where the 20 subnet is, I should push it back to the 10.254 the router then sends it back to the Windows machine, not involving at all this gateway address here. And that's the nice way to play. So what we need to do is we need to put into all of these machines here in this subnet a static route that says, if I want to get to the 20 subnet, push it back against 10.254. We have to put a second one in for anything that wants to get to the 30 subnet, also go back against 10.254. So what we need to do is we need to set up routing and remote access on these machines and put a static route in that pushes those two subnet responses back to the 10.254 card on this router, so that they can deliver the packets to the right subnets. So that's what we're going to do. We're going to set up routing and remote access and set up some static routes in order to send the traffic back to the router rather than bouncing it off the ADSL at the front. So let's open up our web server here, sorry, our server A, and what we want is routing and remote access. So we open up our server manager, click on the dashboard, and we want to add roles and features. Next, and we want routing and remote access, so it's a matter of finding out where that actually is. So if we click on network policy, I think you'll see here that we have access services. How about remote access? If we go to remote access, we've got direct access, web applications, okay, so there's nothing that actually says here exactly routing and remote access. So what we're going to do is we're going to have a click on this one and go next, and next, and next, and we can see that that is actually the correct one. And what we want is routing. Okay, so we're going to add that feature. So we're looking at direct access and VPNs, which is something that we're going to want in the future anyway, but routing is the thing that we really need. Okay, so we go next, and next, and next, and install. And likewise, we have to do the same thing on our web server as well. So if I just flick across to server B, we're going to open up our server manager, and we're going to do add roles and features, next, next, next. Here's our list, and if we can remember, it was in our remote access thing here. We'll go next, 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 and we want routing, and we're going to add the features and go next, and next, and next, and then install. Okay, so we're installing the capability for both server A and server B to have routing and remote access. So let's flick back to server A. That's now finished. And we can see here that we've got open the getting started wizard, which I don't really want to do. I'm going to actually kill that. Well, I can't actually. It doesn't allow me to. I can kill that one though. Okay, so I'm going to go to tools, and I'm going to look for routing and remote access. Here it is. Okay, so this is what we want. Let's expand that out a little bit so we can see. And we can see here that server A has a little red dot on it, which means it's not working. If we expand that out, nothing. Okay, so what we need to do is a right mouse click on this and configure and enable routing and remote access. So it runs this wizard. We'll go next. And what we really want is a custom configuration. Custom allows us to set it up the way we want. At some point in time, we probably want dial-up or VPN as well, or virtual private network access, and that we'll come back to that and see if we can sort it out later on. So we'll go next, because we just want custom. We want just LAN routing at the moment. Yep, LAN routing. Go next, and finish, and start the service. So what should happen is this should then go green. It's gone green. Okay, so we can see here we've got, if we go IP version 4 and look at our static routes, it's at this point here that we can actually put in the static routes that we need on server A to push traffic back directly to 10.254 if we want to get traffic back to the 20 subnet or the 30 subnet. Okay, so this is how we'll do it. We'll go right mouse click in here and a new static route, and we can go, the destination is 192.168.20.0, it's the entire subnet, 255.255.2, 55.0, and the gateway is going to be 192.168.10.254, which is the address of the card on the router. And we'll just set the metric. The metric is the number of router hops that we're expecting to get to that network. We don't really want this thing to bounce around the network for 256 different routers, so we'll just change this back to say, you know, 2 or 4 or something low. Okay, so I might go make it say 4. Okay, and we'll do the same thing again for the 30 subnet. So right mouse click new static route, 192.168.30.0, 255.2, 55.2, 55.0, and the gateway is 192.168.10.254, and we'll make the router hops to 4. Okay, so there's our 2 static routes, and that will push the traffic directly back to the 20 or 30 subnet, and not bounce it off our ADSL. Okay, so we need to do the same thing on our server B. So let's flick across to server B. There it is. It's now finished, so we'll go OK on that. Tools, routing and remote access, and right mouse click on here and configure and enable using their wizard. So we'll go next, custom configuration, next, whoops, LAN routing, sorry, next. Probable reasons: unable to open ports for routing, remote access in the case routers not able to accept. Manually open the port of routing remote access in the Windows firewall. Start the service. Okay, so it might have been a firewall issue. Okay, so this is started, it's green. If we expand that out and look at IP version 4 and look at the static routes, we're going to go right mouse click and put a new static route in. Again, 192.168.20.0, 255.2, 55.2, whoops, why is that not showing? It's not showing. Okay, I think it was a numlock issue. 192, yep, .168.20.0. Gateway is 192.168.10.254, and we'll set that back to 4. Okay, and we'll do the same thing for the 30 subnet. 192.168.30.0, 255.255.0, and 192.168.10.254, and change that back to 4. Okay. Okay, so both subnets are in there. Okay, so that's routing and remote access in place, and we've got reverse routes in place to redirect the traffic back to the client's subnets, so that the traffic does not all bounce off the front ADSL modem. So that will be this video.